2 weeks ago, or really basically just a little over a week ago, I attended a forum, or not a forum, a conference, I guess, and I need to mute people out there. Hold on. Some people are echo from someone. All right, that's better. Sorry. So a little over a week ago, I attended the O'Reilly Open Source Conference in Portland, Oregon, and I attended several sessions, and so my plan was to present something from that conference. I only mention that because the presentations at that conference were all scheduled for 40-minute time slots, and most of the presenters were very good about ending early so that they had enough time for questions. So if I was to present this exactly like the original presenter, it would be like a 35-minute type slot. What I hope to do is finish at that about time, and then do a little bit of extra material at the end, with kind of weaving in some that I learned from a different session. And then if we finish that, then possibly just talk about the conference at a general kind of meta level, things about what seems to be popular, what seems to not be popular, and kind of what are the observations of the conference and whether somebody would want to attend it. Okay, but to start out, the actual topic that I attended and that I want to repeat here was titled Painless Data Storage with MongoDB and Go. These slides will be available later. I do want to call your attention to this presentation was given actually twice, once at the conference I attended, but also previously at another conference called the GopherCon or Gopher Conference in April, and the presenters then were Gustavo and Steve. They are really kind of the primary developers on the actual MongoDB Go driver. So they're very good in terms of getting it from the original source. And that presentation was recorded and is available on YouTube. So if you're really interested in this material, go watch that video instead of mine, because I'm sure they do a lot better job. I don't think we'll have time. One of the things from that video, though, is at the end when they do questions there, again, it's about the same amount of time slot. It's about a 35-minute video. In the last 5 to 10 minutes, you can tell in the YouTube channel because the screen has got that little kind of slides in the top left and then the picture of the speakers in the bottom right, and the slides go away and it's just then the speakers and kind of the full screen mode, and that's when you can tell you're in the question answer period. And one of the questions that I think, given that we just had the talk on Cassandra, that somebody asked was, a lot of people, this is the guy asking the questions, a lot of people say that MongoDB can't scale, and can you kind of address that question? And so he does a really good job of answering that question. Steve Francia is actually from MongoDB, the company that's now sponsors the driver. So anyway, I point you to that video in at least the last 5 to 10 minutes if you want a good answer to the question about can MongoDB scale. I'm not presenting this talk because I'm a big fan of MongoDB or of MongoDB. I am a big fan of Go, the programming language, and we'll get to that a little bit more in a second. All right, so I'm going to go through kind of 2 sections at the beginning here, and the first one is why Go? Why the Go programming language? So let me put up the slides, and then I'll add in my own personal feelings as well. So why another another software programming language? Software, you can kind of look at a few problems that the original authors of the programming language were trying to solve, or at least problems they had to deal with as part of their regular jobs. Software itself is slow. Software is hard to write, and quite often software doesn't scale well. So how can we address some of these problems with Go, or how does Go choose to address some of these problems? Well, the execution speed is very, very fast. It's not, I'd say it's better than Java, but it's not as fast as C. I would say it's better than Java only in the perspective of, I believe the language authors kind of recognized, they had the hindsight of seeing over 10 years of Java before they got to writing Go, and so they could do things a little bit differently. They didn't have to obey all the same kinds of rules. It does compile into machine code. It doesn't compile into bytecode like Java does. That said, it does have a little bit of a JVM aspect in terms of there is garbage collector and some other routines that the infrastructure is taking care of for you. So the speed is probably between C and Java in terms of my most familiar languages. In terms of comparing it to others, I don't know the other languages like, say, Python well enough to kind of give you a comparison to that. I will say that from a couple of years ago, one of the things that the language authors were surprised at were how many interpreted languages like Python, people from those languages were adopting Go, because Go is not an interpreted language, and they were really surprised by the adoption. And if they were making guesses, they feel that one of the guesses is because of the compilation speed, and the execution speed is so fast that it gives people the same kind of interactive feel that they had in the interpreted languages, even though that's not exactly what it is. So that gives you kind of, that covers off on that first bullet. In a lot of ways, it has a dynamic language feel because of how fast the compilation is. It's very small in terms of the language spec. They were very, I heard this more often at this conference than I have the other times I've attended sessions on Go. The Go language specification is only 20 pages, and when you look at other language specifications, they're not just 800 pages; they're hundreds of pages. The poster child or kicking thing that they like to kick the most is obviously C++, which is where these language authors were before they invented Go, and I mean that's literally over 1,000 pages. I mean, I'm not sure if it's hit 2,000, but it's probably pretty close. The C++ specification is just insane, and the Go programming specification is 20 pages. They're very, very proud of how small it is. The other thing that happens with Go, whether this is friendly or not, I guess you would have to make your own opinion. I did hear one person ask and kind of second guess this point, but it only produces a single binary. There are no dependencies. There's no such thing as a dynamic linked library, a DLL in Windows, or a shared library in Linux or anything like that. So you don't, if you're going to install your binary, you don't have to worry about, were all my dependencies there? Did somebody install this version of libc or this version of libxyz? None of that. Everything is one monolithic binary when you compile a Go program. And that makes it very easy to kind of like take that and go someplace else. The other thing is that there's the cross compilation is built in. If you download the Go application, mute, please. Don't know who that is. Thank you, whoever it was. Cross compilation is built into the compiler, so it's very easy to have your Go distribution on your Linux 64-bit operating system and compile for, say, the Mac or a Windows or any other platform. Most of the platforms, the cross compilation is just built in with the distribution that you get. The extensive tooling and standard lib, I'm not really going to cover off on that. I think every language is going to claim that they have extensive tooling and standard lib. I will, if time allows, show you a couple of the tooling that I think is very interesting. I do think that, as one example, this right here is a Go tool, this presentation format that we're in now, and we will see later on running code from this kind of PowerPoint presentation. That's just another one of the Go tools built into the language and ships with the language. And finally, I think this is the last bit on just general Go. Go is concurrent. So the concurrency is built in from the very beginning. You can kind of say that's true with a lot of other languages. Like we can go all the way back 10, 15 years and say, well, concurrency was built in with Java right from the very beginning. It had a thread class, and 1.1 had a runnable class, and it was just right there right from the very beginning. But I think Go, it's built in, but they've taken a little bit of a different approach from Java perspective. It's a very common approach defined by one of those very, very smart PhD people that wrote a paper, and here are all the concurrency principles. And these concurrency principles are adopted in many other languages, including Erlang and some of the other variants, and Go has a lot of the same concurrencies. One of the things I will mention in terms of Go concurrency and the Go routines is that they are not threads. Where in Java, threads are very similar to the actual thread of the OS. Go routines are not equivalent to threads, and you're not going to get a maximum number of like sub-processes or a maximum number of threads error in Go. The virtual machine, if you want to consider it that, manages all the Go routines and does all the scheduling itself. And so you can spin up millions of Go routines and never have a problem. And that's a lot different than a language like C or C++ or Java, where there's the one-to-one mapping between the threading and the OS level abstraction. And then there is one other thing to mention, though, I think, at least in comparison to Java, is channels. Channels are a concurrency communication thing, and that's built in. The closest that something like Java has is just that you have a lock, and you have locking primitives of things like synchronize, whereas channel is a communication pipe between Go routines, and that's not just a built-in data structure, that's built into the language syntax itself. All right, so MongoDB, I'm going to not go fast through this, but I'm going to go pretty fast through this because I'm not the expert, and I would not do it justice in comparison to our last presentation. A lot of what they were trying to present here was not comparing MongoDB to other non-relational databases. A lot of what they were trying to do was compare it to, why would you use a non-relational database over a relational database? And their statements are, you look at relational databases and you're going to think of them slow. I think that's a little bit extreme. I think you have to tailor that statement a little bit to they are slow in X, Y, or Z situations. And then you can say, and in that specific XYZ situation, this database or this storage is faster in this other way. But there are many situations where relational databases, especially at what this hot topic buzzword of web scale is, considered, there is some significance to scale and why people start to say relational databases start to slow down. Relational structures don't fit very well. Scott mentioned earlier ORMs, in terms of you have to kind of break yourself away from ORMs to kind of get into doing things the Cassandra way. Well, ORMs are kind of a reason or are example why relational databases aren't a perfect fit. ORMs wouldn't exist if it wasn't for the fact that the relational database kind of metaphor feels wrong to a lot of programmers. And so these ORMs get developed to kind of take the place of not needing to worry about the relational aspect. And the last one is databases don't scale well. This one is a little bit, again, hard. You have to kind of put a little bit more context to it. And for this one, I'll pick on Oracle. If you want to have an Oracle, what is called, essentially like rack, but essentially an Oracle thing that will span more than one physical hardware thing, you pay lots and lots and lots and lots and lots and lots of money. Okay, it's not just a little bit of money. It's an extreme amount of money. And so if you have an application like many of our clients who adopted what they perceived at the time was the best relational database out there, and they adopted something like Oracle, and now they have to grow beyond the constraints of one physical piece of hardware, they are now in for an extreme amount of money. And so, you know, don't scale well, at least don't scale well without giving Oracle lots of money. And then if you take the free relational databases like MySQL, MySQL didn't scale well either. That's a lot of Cassandra comes from MySQL background. A lot of other databases come from the fact that the open source options, the non-money options, just didn't scale well beyond one physical piece of hardware. Okay, MongoDB is written in C++, so it is going to compile down to machine code, which should make it faster than if it was written in another more interpreted type language. It runs everywhere in terms of, I mean, it's not just something that was developed in like Red Hat Linux and that's all the developers pay attention to, and they don't really care about supporting something like Windows or Mac or whatever. You know, again, we're kind of going back, but like 15 years ago when Java first came out, it was really hard to get a JDK on Linux, you know, because they weren't supporting it to begin with. You know, and so it's when you look at an application these days, we've come a lot farther, but it's still very important to know, okay, yeah, you don't have to worry about you're a developer on Windows, you got a developer on Linux, you got a developer on Mac, you can run this in all those places. That should be the standard, but it's not always. The best example I have of that in current day is when someone who is trying to explain something to me in Git and brings out source tree. And I'm like, I'm sorry, I can't run source tree off my Linux box. Please tell me how to do it in something that everybody has access to, not just the Mac and Windows users. Okay. Philip just messaged me because he's the common culprit on my current project with that. So BSON is something we'll talk to you about a little bit more here in a second. That is the primary data storage format. It is not JSON. It is very easy to misunderstand this, and I'll try my best to explain it here in a second, but it's not JSON that's stored in MongoDB. It is BSON. And full support for different kind of indexing. And then we'll talk about document model, but the document model hopefully gets back to kind of that ORM point, which means you should have a lot less programming work to store things into MongoDB because how you're storing the data should more closely map to the way your data is in your programming application to begin with. All right, just some of the other random bullet point queries for MongoDB. It does support ad hoc queries. It's not limited in certain ways. I'm sure there are limitations, but I couldn't delineate those for you. traditionally consistent. Again, if we wanted to bring out the cap diagram that Scott had, it does fall in a very specific place on that thing. There is, we'll see a little bit here in a second, but they do have a concept of just kind of like a single node or a replica set or a sharded instance. And how you use that does kind of affect where again on that cap therm triangle you end up falling.
Hey Chris.
Yeah.
Sorry to interrupt. So Seema pinged on here. Apparently the YouTube channel is displaying my baby photo rather than your screenshots. And I just checked. It is.
Thank you. I will go in like that. Apologies. Anyway, for the people that are watching this recorded, I will go back 3 slides really quick.
And you're welcome for my baby photos.
All right. So these slides, again, will be available later on, but here we go. So the video, and then WIGO. Most of this we talked through. Just kind of, whoops, didn't pause long enough on that one. Again, just enough that you can hit pause on the YouTube channel if you want to read these slides. All right. Flexible schema. I will hopefully demonstrate the flexible schema during this presentation, so pay attention to that if it is of interest to you. This gets into a little bit of the question about like how easy it is to alter your thing. I don't have examples in the presentation of changing a column's or a field's data type or removing a thing, but I do have an example of kind of adding on the fly columns. And then support for a lot of programming languages. You can go out to the MongoDB site to find the drivers for the different languages, but I think the fact that I am giving you a presentation against one of the newest programming languages against one of the newest databases should give you an indication that there's quite a few drivers available. All right. Again, hit that video and hit the question on the does MongoDB scale in the YouTube video from Steve and Gustavo. They will give you examples, kind of spill the beans a little bit, of Disney and MetLife as 2 of their biggest client customers with very large institutions. And so I do think they do consider it scaling bigger than kind of your traditional databases like MySQL and Postgres and that kind of stuff. Okay, so a document database. The document database is designed not to store. This is very difficult to wrap your head around at first when you're just trying to cover it at a very general level. It is not designed to store JSON documents. It's not designed to store PDFs or Microsoft Word files. It's designed to store a thing that is different, called different things in different programming languages. And so if you had a JavaScript heavy programming language, then yes, it might be a JSON object that you're storing. If you are in PHP, it's probably, as you can see in these different languages, it's a PHP array. In Python, it's a dict. In Ruby, it's a hash. In Java, I don't know that we have the best example, but you'd probably, if you were really going to stretch things, probably either a map or something kind of akin to that. But map is probably the closest to Python dict or Ruby hash. Okay, so data serialization, the application does, their goal, well, as they talked about it through their presentation. I have a hard time believing that someone stood back and developed MongoDB with this in mind, but maybe they did. They say that their goal was to kind of develop the database right from the very beginning so that it could be accessed from many different programming languages and yet still have this appeal of being able to store closer to the programming language type thing. To be able to do that, though, to be able to have kind of comparison between like Ruby hash or Python dict or a JavaScript JSON object, some serialization is going to need to take place. And so the goal of that is for the serialization to take place at the driver level and not at some kind of like ORM level that gets added after the fact and not at necessarily the programmer level. And that gets us into the BSON that we'll talk about here next. So BSON is their way to accomplish the serialization. They do claim it is inspired by JSON, but it's called BSON because it does handle a binary serialization format and not just the kind of text ASCII or text kind of character format that JSON does. And it has also got a little bit of optimizations built in for scanning. And finally, it does have a little bit of support for richer types, not just the binary types themselves, but for kind of more native types, whether it's to numbers or geospatial type data. Okay, so MongoDB and Go. I'm not going to explain a lot. I will try when we get into code to point out some of the Go syntax, but I've done that presentation before, so I'm not going to repeat it. You should still be able to follow along if you don't know Go right from the very beginning. But in Go, there are two two data elements or syntax elements within Go that are MongoDB persistable things, and the one is a struct and the other is a map. A struct is very much from kind of the C type terms where it's just a collection of different fields, one field, one value, one field, one value. They each have a separate, each value of the struct has its own type. And a map is again a native syntax thing, kind of like an array is a native syntax element in Java. A map is a native syntax element within Go that is basically a key value type pair. And all the keys are the same type. And the values are supposed to all be the same type, but Go does have this concept of interface, which, because they have a concept of interface, lets the values, if you really wanted to, be of any kind of type. So if you have a map of whatever your key is to an empty interface, you're basically saying your values can be anything. All right, so the first code example at the top, I have these split because they would be in two different sections of the file. And at the top, where I would be defining my types, I have a struct defined. The struct is a type, so I can create then variables later on of that type. In Go, the variables names are first, and then the type of the variable is second. This is inverted from C, C++, and Java, where the type is first. So we have a named field in this struct, which is of type string, and we have a birthday field in the struct, which is of type time. The first part of that is just basically the scoping that time type is in the time package. So in the second section, kind of somewhere down in my actual runnable code, I'm creating a new variable called Bob. The colon equals basically defines that the type of Bob will be whatever the right-hand side is. So it's kind of defining the variable and assigning it in one command. And the value is going to be a literal, so it's kind of like A literal in Java is just, like a double quoted string or a number. This is a struct literal, so it creates a struct right there, and which has the value for the fields of that literal of Bob and now, basically, for the time. So this guy was just born.
Does that mean it's immutable, or is it just?
No, it's just basically like if I was the equivalent in Java would be saying Bob is equal to double quote Bob double quote. It's just a literal, so it's enabling me to kind of create assign a value right here without having to like create a new struct and then insert the fields one at a time. All right, so we have our Bob object, which is a variable of type person. And then to Marshall, we're basically calling Marshall dot on the object, which then returns you two things. So this is another Go syntax element where functions in Go can return more than one value. They can return two values. And so we return both a value called data and a value called error, or at least those are the variable names I'm using. Error is basically kind of akin to like exceptions in Java. If an error occurred, then that error object will be some value. If it's nil, so then that means there wasn't a problem and I can continue on. But if there was an error, then maybe my database connection isn't there, something's not going on, I don't even need to bother. Panic is kind of like the equivalent of system.exit. Okay, so data is returned as basically a byte array or a byte slice technically in Go terms, but it's basically an array of bytes. It converts it from the struct thing to a kind of a binary format. So I'm going to print out that array of bytes, and then I'm going to turn around and then take that array of bytes and then unmarshal the array of bytes back into a new person object. So right up here, my object was Bob. Down here, I have a new variable person, and I'm going to marshal that into, or unmarshal it into the person object. Go does support pointers in a limited fashion, not as wide open as C and C++, but it does support pointers, and so I'm passing the address of that in there so it can modify it in the function, and I see those modifications outside of the function. All right, so if I run this, we see the array of bytes, and then we see the value of Bob. And see, this is 1629.35. If there's any doubt that this is real time, we have a new timestamp there. So it is running the code as it runs. Okay, so equal after marshalling. There are different ways to, or different things you can kind of put into MongoDB or put into the MongoDB driver calls. They do get marshaled into bson. If you have a struct, Go does have something that is a little bit like annotations, and I would say they're exactly like annotations, but they're not called annotations, so I'm going to say they're like annotations. They're actually called technically tags, but that's what this stuff over here is like an annotation that then the MongoDB, the bson driver can read and interpret and do stuff with. So it gives you the chance to give it hints. And in particular, it's basically just is use here. What is the effectively to use a relational database term? What's the column name going to be inside of MongoDB? You don't have to specify this, but you have the ability to if you choose to. Another thing you can do instead is you can actually use a map, like I said, and you can also do a document slice. This one is really difficult to decompose without knowing a lot more about Go syntax, so I'm going to skip through that one. But the map, hopefully you can see this is a map of string keys to string values. So you can see here, this is the key, and then this is the value, this is the key, this is the value. These would be variables that were, got their value somewhere else in the program. Oops. Okay, so MGO is the package name for the MongoDB, or the MongoDB driver. They pronounce it Mango because the way you pronounce certain programming terms is very important to some people, and so they've made sure that you know how to exactly pronounce MGO. So it's Mango. It is written in 100% pure Go. Because you can drop into native code from Go, or native code being like something like C, just like you could from Java, and they just wanted you to know that they didn't do that. It's all 100% Go code. Go as a programming language that other people besides an internal group of Google people could use was created in about 2009, and so and that was about mid-2009 that it was first released to the public. And so Mango, in terms of a database driver being created in 2010, really is only about 1 year plus a few months after the language came out, which is pretty early. And they will tell you that this was one of the first database drivers kind of really publicly available for the Go programming language. Gustavo in the YouTube video does a good job of kind of explaining why he developed this, and it really was a matter of he needed to do some stuff. He's from Canonical, and he needed to do some stuff at Canonical, and he was basically faced with the question of where do I put my data? And he was writing Go, and he decided to, he tried at first to write his own essentially database or his own kind of data storage, not necessarily full database, but as he tried to write his own data storage, realized I'm going to end up writing a database. That's kind of silly. Why don't I use an existing database? And so he needed then a driver to get stuff into whatever database he was choosing to use. So the original author, Gustavo, was from Canonical, but in 2011, MongoDB, the company, did start sponsoring the driver itself. Again, MongoDB was trying to support multiple programming languages, so it's not like they ignored, Go at first. They just had a lot of different languages, and they've adopted and finally started supporting Go as well. And Steve Francia, who is one of those two presenters, is from MongoDB. Okay, so to connect to MongoDB is pretty simple. You just do the dial command. Dial might seem like a silly kind of name when you're used to JDBC and Java.SQL, but dial is an idiom in the standard library. So if you go to what are the libraries that ship with Go, and you look in the Go library, they do have their equivalent of, say, Java's Java.SQL. In Go, if you look at the standard library, their standard mechanism for opening a connection to a database is called dial. So Go, or Mango, the MongoDB driver in Go, is just trying to follow Go idiomatic conventions where possible. So they use Go dial, and dial basically you just pass it one value. It's the same way to connect to whether it's just a single node server, a replica set, or a sharded cluster. The driver kind of handles taking care of all that for you. You don't have to build that logic into, do I make this call in this circumstance, or this call in this circumstance, or this call in this circumstance. It's just one call, no matter what the topology is behind the scenes. Okay, this is a little bit of, the code at the top is pretty common if you're using the kind of base Go, without using a framework, the base Go support for doing web server type stuff. This would be the equivalent of like writing a servlet, a raw servlet, rather than using any kind of framework. But anyway, that's just kind of trying to give an impression that we're in some kind of web server handling, and they really wanted to try to draw your attention to this .copy. In terms of the session that you get back from the previous slide, the session you get back from dial is a lightweight data structure, and that data structure can then be copied as many times. So you can put it into one of these millions of Go routines and not worry about doing the copying. It's not an active, open socket connection that you have to worry about connection pool handling and all that kind of stuff. They really encourage you to copy the session, and then you can close the session when your particular code is done with it. Defer is a little bit like the recent Java syntax element, kind of the try with resources where, these are things we want to happen, after this block of code. It basically defer will happen when the method completes. I wish I remembered what they were trying to say with this, other than this is kind of the next level of first we get our session, and once we have our session, we want to do something with our session. So the first thing you get back from us, or one of the things you can do from a session is basically say which database within that MongoDB system you want to connect to. So this is the database name. It's kind of like a table space, maybe in using kind of MySQL or Oracle kind of terms. And then this would be, again, using relational terms would be like a table. But basically everything in MongoDB are collections, and collections are similar types of data. And so we connect to a specific table space or database, and then from there we're saying we want to get projects. Another Go idiom is to use very, very short names most often. And so you'll find the things like this where it's just DB and just C, and it feels like it doesn't read very well when you're coming from Java and you got these, argument names that are, 50 characters long. These people are coming to developing a language and trying to develop idioms from pain points that they'd experienced before they got here. And so they wanted to basically flip things back around, develop easy-to-read code, and for them they said, short variable names make it easier to read, because we all saw what happened when we got to really verbose long variable names, that wasn't good either. Okay, so now that we have our database connection and we have a collection in MongoDB terms, we want to put some data in there. Again, I'm going to kind of go back to, we're going to have a type. So I got a struct here with a name and an import path. This is really dealing with imports that you do in Go. That's why I was talking about import path, but this is kind of like the name of the project, and then if you're using that project, what's the thing you put in your import statement. But you see here an additional BSON annotation or tag, which is omit empty. Basically, if this field is not filled in, and so it has the kind of the equivalent of the null value for that type, then it basically will not persist any value to the database. It does not persist like in a string terms. It won't persist an empty string. It will persist the equivalent of null. And so it knows the difference between no data and like an empty type or a zero type. Okay, so this is insert. I've again included some code, but not all the code necessary. So we don't see the dial command within this code. But we do see getting, once we have the dial command done, we have the session, getting a hold of the test database, and then going into projects. And once we have projects, this is just an array of the struct from the previous screen, a bunch of different struct literals into this array, and we're just iterating through that array and basically calling insert on this MongoDB collection. Okay, the only thing that we print here, if it was done, is okay. But before I run that, I need to screen share my entire desktop for this. And it won't look quite as good to everybody else, but I want to show you. Okay, so oops. There it is. So this is my MongoDB shell on my local host, and I just wanted to show you that right now we have a test database. and I'm going to drop that database to show you that we are starting from scratch. So I need to do switch to that database and then drop the database. Okay. So we have no test database. This is important. So now you can see that right now I'm going to connect to a database that doesn't exist, and then I'm going to connect to a table that doesn't exist, and then insert data into that table. And our program did not panic, did not have any errors. It just says, okay, it reached the end there. So you can see the test is there, so I'm going to use that database. And you can see if I do show collections that we see the projects. And if I look inside of that collection, we can see the data that's inside of there. Okay, this is just so you know that I'm really connecting to MongoDB in the background during the rest of these slides. Okay, so to update, this is showing you a different form. Instead of using a struct, this is, or I guess in addition to using a struct, we're using a map. And so in this particular map, I found this a little bit odd, and I think it has to do with some of the MongoDB conventions that I'm not yet familiar with. But they basically have a command, and this is basically set, and then they pass in the different field they want to update, and then the value they want to update that field to. And then they pass in a different thing to kind of identify the key, and then that map that indicates a change. So this is updating essentially the QML object to the .1. So if you look at right now, we have QML is this one. QML is .v0, and if we run this, we can see that it got updated to .v1. Not super exciting, but that is one way to do an update. So querying, and now hopefully I don't have to drop back to that terminal anymore. We can find different, one mechanism is with the find, and then you can pass it a specific kind of key. What is returned there is an actual collection, so we can do a dot on the collection right away and basically say I just want one of those. If there was more than one, then it's going to error. But if there's just one, then that will succeed and fill this particular value. And then we print that right there. Whoops. We can get back V1. I can't remember. I think I can update this. So we look at one of the other ones was pipe. I haven't done this. I should have done this before now, but I think I can do this. Yeah, so it's live editing of the actual code. All right. If you wanted to get a group of things, not just one thing, they do a concept of an iterator. Like I said on the previous slide, find does return a collection. So from the collection, we do the iterator, and then we can take that iterator, go over the collection. You can see here by passing in a pointer, we can fill that object, but yet have the result of next basically be the Boolean yes, true, there was another one or not another one for the loop control. And we can get all of our different values out that way.
Mine's a nil. Find nil.
That's the null. That's like saying null in Java. It's that they're syntactical elements to mean not set.
It doesn't just support default arguments or anything like that.
I'm sure they could have written a a version of find that didn't take an argument, but I couldn't explain why they decided to do pass a nil rather than call a method that has no arguments. I don't know.
So it doesn't work if you pick that up.
I didn't try. Nesting. This is kind of to try to convey that we do have we can kind of go down arbitrary levels. So here we have a struct, but within the struct we have another struct. So we can have embedded types. We can go kind of deep that way. In addition to an embedded struct, we also have an array, technically a slice, but slice array are nearly synonymous. And so we have an array of strings here that take 2 values, and then we have an embedded struct thing. I am going to exactly the same collection that we had before. Okay, so let me back up and run this. Remember, we got 4 go check QML pipe YAML. And now I'm going to do this with a new one, go dep, and I'm going to have a tags and a contact. And I'm going to insert that. It says OK. And let me go back and run this. And it has go dep. Now you may ask why it doesn't have anything else there. Well, we didn't print the import path. And this particular program that I have attached to this particular slide has the old definition of the structure, has the name import path structure. So when this particular print happens, it's printing the structure as this particular program knows about it, not the one that this knows about. Okay, this is just nesting in another way, kind of defining things. Well, this is actually, I'm sorry, pulling the things out. So here, where we weren't seeing the value, because this structure, this one didn't have the definition. This one is just basically kind of the reading with the deep structure. So if I can run this, I would basically get that thing out and have a different thing. It does use a not primitive or not part of the standard language library. It's using a pretty print package, which handles nested types a little bit better than the standard library does. Indexing, just that MongoDB does support the concept of indexes, and they're very easy to do from your code. You don't have to do them at just the database level or in some kind of like, DDL type statements. Okay. Go has the concurrency primitive I talked about earlier. Go routines. Go routines are similar in field to threads, but I don't have enough time right now to kind of get into the differences between Go routines and Java threads. But there is a little bit difference. But this bottom section of code, just trust me that because I'm using the Go keyword, I'm basically saying I want these two to run in parallel, and this will be supported. I have it as a comment because I didn't want to run out of room on the thing. But basically, if I didn't do something else past this, then the main program would finish before the Go routine. Potentially, there'd be a race condition, and the main program could finish potentially before the Go routine's completed. And so I do create a channel, and these Go routines are passing data into the channel, and I have later on in the code basically reading data from the channel to make sure that I wait for those Go routines to finish before I let the main program finish. Okay, so this just basically shows that we can do the finds concurrently, no problem with the database driver. I'm not going to cover this in detail, mainly because I'm running a little bit short on time, and I wanted to possibly show a little bit of Docker. They basically are trying to convey that you can write code with especially older code with older database drivers. And if you don't use a database connection pool and you don't pay attention to your concurrency, you're going to get kind of some pretty bad performance because you're going to basically issue the first find, wait for the database to finish the first find, return the results, and then before you do the second thing. And they basically are trying to say that as long as your code can concurrently call the Mongo driver, the database driver concurrently, then it'll handle multiplexing those and making sure the queries are happening in the database concurrently. I didn't spend a lot of time in these slides because I don't think that's really a problem. In most other languages, we know to use database connection pools when we have concurrency in our application. They're just trying to say that in a little bit of a way that it's handled at the database driver level. You don't have to do it at kind of a database connection pool type level. They do have a concept of batching, so it's built into the driver to do batches, and then the kind of how much of the batch gets loaded to begin with. We've already talked a little bit about the lightweight sessions, so I don't think I have anything more to say here. We kind of covered that earlier. But the main thing they wanted to show was kind of refresh your memory of what we talked about here, and then basically say, well, if you don't do it, and you just basically take the same session into a whole bunch of different threads, you'll still get pretty good performance because the database driver is pretty smart and is able to kind of do things intelligently behind the scenes. It's better if you copy the session, but if you don't, you'll still get pretty decent performance. It's not going to be serial. It's not like you're using one database connection and that's it. All right. GridFS is something that they kind of defined at the generic Go level, that they wanted as much as possible different databases to kind of implement ways to store, I want to say ways to store binary data. So if I was going to kind of put this in relational terms, it'd be a little bit like saying, well, we got the SQL standard, but we know SQL is not perfect, so blob. Let's have a blob concept that kind of is the catch-all, and that every relational database will implement blob. Well, kind of the Go level, they basically said, we'd like all the databases, whether it's Cassandra or Mongo or MySQL or whatever, we'd like all of them to kind of implement this interface of GridFS that kind of gives the application code the ability to kind of treat the persistent storage in a way that's a little bit like a file system where you have open and read and write kind of commands without having to have these kind of really difficult to manage things like blob type constructs that we had in java.sql. So this is a very simple example. I'm basically, you have to take my word that I created a binary thing called, I'm sorry, it's not here. This thing, ISO, is a binary file that I opened from the file system. And what I'm going to do is create into the database a new thing called cd.iso. And I'm basically just using the straight vanilla Go I/O routines for copying, passing it readers and writers. And it just runs very, very quickly. So whatever that is, 4 megs in 24 milliseconds. Not too bad. All right, so we're just about out of time. There are some other things that are kind of not part of Mongo, or they're kind of being developed later on. One is transactions. I know that we're used to having transactions in relational databases, but you have to come away with that is in a different relational database like MySQL is in a different place on that cap triangle than something like MongoDB or Cassandra. So transactions aren't a given because that's not the role it's trying to play. That said, being able to kind of say, well, what if I was to give up this other aspect and to gain this thing? And so they're trying to develop a library that would give you the ability to kind of give up one thing to gain another thing. And they do support being a connector both for input or for output to Hadoop. And so this particular presentation, in conclusion, they basically say, it's really easy to get started. You just have to install MongoDB, which is pretty short. And then Go Get, which is the way that you pull down libraries, additional libraries. The closest analogy I can give you in Java would be to say this be like the dependencies that get pulled down automatically by Maven when you're just doing Maven builds. In Go, you have to kind of pull your dependency down before you do your compilation. So this is kind of pulling the dependency down, and then start small, build something great. Just some resources. These are hyperlinks, so if you look at these slides later on, the MongoDB manual, Effective Go, obviously going off of the Effective Java book that a lot of us remember from early in the Java days. Kind of trying to cover what are idioms that aren't baked into the syntax, but things that you should do in kind of a standard way. If you have specific questions on the MongoDB driver for Go, then this is the website where those instructions are at. And SPF 13 is the website for Steve Francia, who's the guy that presented this material at the OSCON conference. And so I would point you to his site as well. All right, and we're just about out of time. In the last couple of minutes, I just wanted to share really quick the highlights of the highlights, because I won't be able to get through all of these from OSCON. One of the things I was going to show, if we had enough time, but we ran out, was to show doing some of this stuff with Docker. John Lewis did a Docker presentation within the last year. Me and Bill went to OSCON in 2013, and I don't think either of us heard of Docker before that conference or at that conference. And if you went to OSCON this year, 1 year later, Docker was everywhere. I mean, it is amazing. It's been a long time since I've seen a particular technology of any kind have the uptake that Docker has going to the same conference 1 year later. The uptick on Docker is just insane. If you do not know Docker and you did not attend John's presentation, you need to do something to start to pick up Docker and learn Docker in at least at just the book presentation level so you can talk intelligently about it. It is the most important thing coming out of OSCON. The second most important thing, well, I should say, it kind of maybe a tie. There is a technology for doing things with Docker called Kubernetes, which is a technology that Google released to kind of help you manage Docker containers in kind of cloud environments. It's very early. I wouldn't say it's ready for prime time, but if you're learning Docker, you will probably see people start to use Kubernetes like they're using things like Chef and Puppet and Ansible and SaltStack right now. And so that would be kind of one of the other observations is last year, in 2013 at OSCON, I'd say, you saw Chef and Puppet, if not completely equal, even if one was showing up more than the other, you still saw quite a bit of both of them. This year, I think I may have heard Chef referenced once, but Chef has kind of dropped out and seems to have lost the war and is not being used much at all. Whereas I'd say the other three, Puppet, SaltStack, and Ansible, which are all kind of comparable to each other, are all kind of, I'm not sure there's a clear winner between the three of those, but Chef certainly seems to be the loser of the bunch right now. And finally, I'm not here to tout MongoDB. I found the presentation interesting. I thought I would present it. But even though I'm not a big MongoDB fan, I did a NoSQL presentation, I don't know, about 5 years ago to the same group and presented you with a list of things. And I probably, at that time, had a higher opinion of Cassandra than some of the others. But I gave you a list of like 4, 5, 6 different technologies, the different people that were using those different technologies. Go back about 10 to 15 years when the open source databases you had to choose from were predominantly MySQL and Postgres. And at a book level, you could basically say Postgres was kicking the ass out of MySQL. It had a lot more support and was just frankly a better database than MySQL. And yet, roll forward about 5 years, MySQL won. Postgres just did not get the adoption that MySQL did. For every 10 installations of MySQL, you'd be lucky to have 1 installation of Postgres. MySQL just dominated Postgres. And if you look at presentations at OSCON and the number of mentions at OSCON of different technologies, MongoDB seems to be doing the same thing that MySQL did to Postgres. There seem to be more mentions and more uses of MongoDB than any of the other comparable technologies. I'm not saying that it's winning. What I'm saying is if you don't know MongoDB, you probably have a very good reason to know it. Just like you may have wanted to be a Postgres, aficionado and have all your clients use Postgres, and yet it would be hard to do that because all the clients were on MySQL. So similar, I think MongoDB is worth learning, even if it's not the best technology, because it seems to be one of the most popular technologies right now. All right, we're out of time. We're over 5. I do have a few little things from OSCON. I have a bunch of these little 1 year of hosting at Bluehost. If you want to put up a simple website and you just wanted some place you could do that for a year of free hosting, I got about 10 of these. And then I got some stickers of various ilk, Git, OSCON, O'Reilly stickers, 1 Stack Overflow sticker, 1 GitHub sticker. So you're free to take those. We're out of time. Thanks, everybody.
Thanks, Chris.
Yeah, thanks, Chris.